Thank you for that very saccharine introduction. As my evaluator mentioned, this is going to be a question and answer session. So if you have any questions, please write them down, put them in your head, and I will get to them at the end of the presentation, I swear. So as many of you probably know me, my name is Edgar Solorio, and this whole presentation is going to talk about what I do on a day-to-day basis. And it's going to start off with a simple question. What do I do for a living? This is one of the questions that I used to get really scared getting asked as soon as I got out of college, because most of the time I would reply back and say something along the lines of, I work with embedded systems to design and program casino industry-based applications. And most people would just give me this type of reaction. I'm like, oh, what? Oh, that's cool. And to avoid that kind of conversational suicide, I want to teach you guys what embedded systems are. And I promise it's not scary. I'll make it easy to learn. And hopefully you guys can interact with me and ask me questions about what I do. So what exactly do operating embedded systems do? Well, a lot of you actually interact with these things on a day-to-day basis. For example, a Fitbit. These little guys here have a tiny little processor, a little battery, a little display so you can see results. But it also has sensors. It can detect my heart rate. It can detect the number of steps that I take based on an accelerometer. It has special software as well. So it can even detect my sleep patterns at night. It can tell me how much REM sleep, deep sleep, or awakeness I've had over my nights of sleeping. Another one, too, are smartphones. We all know what smartphones are, right? Hopefully all of us have adapted to a smartphone at this point. But they're really good because we can interact with a touch screen. We can make calls with a microphone. We can hear relatives through a speaker. We can even connect to the internet and post Facebook pages about our cats, our dogs, our family members, whatever it is, and receive scorning comments back from the internet too. But we also have all these other software applications, right? There's literally an app for anything. I have an app for a timer running right here on my phone. We have flashlight apps, we have maps, we have GPS locations, we have social media, we have timers and alarms. And just with one single embedded system platform, it opens up the world of endless possibilities with software. And these kind of things are things that we're all familiar with, but there's a lot more embedded system out there in the world that we may know exist. For example, like a security system. This is still an embedded system. It still has a processor with inputs and outputs for buttons. We can have a little display that tells us when the alarm is set up. We have peripherals outside. So like a camera that can stream images or videos and store it locally onto another computer at home, or maybe even send it directly to our phones, so wherever we are in the world, we can check what's going on at home. And then we also have other outputs like alarms. So if we have an intruder that goes into our house, our motion sensor will detect them, and then it'll send an alarm out and hopefully scare them off. These are all examples of what embedded systems are. And hopefully you guys have kind of nitpick the terminology that I threw out in terms of software, hardware, peripherals, and that kind of leads to the next section. Since some of these are very complicated, they can get really robust, but most of the times there's an easy way to think about all this thing. The big picture is you have hardware, you have software, and you have I/O, which is inputs and outputs. Hardware comes in all shapes and sizes. For example, it can be as tiny as a little Fitbit. It can be as massive as a printing press. It can be an ATM that you interact with to get and to withdraw and deposit money. And then you have software, which I'll talk about these two in the next slides a little bit more in depth. But the software as well. There's two main components. You have the operating systems, and then you have the application codes. And then you have I/O, which I usually like having the most fun with. This is how your embedded system jumps from the world of little components and abstract code and becomes much more reactive to reality. Just like how our bodies, we have hardware. You know, we all have legs, arms, fingers, heads. We have hearts that pump blood to our organs to keep us alive. We have I/O. We have ears so we can perceive sound. And we have algorithms as well. So we have two ears. We can actually not only detect sound, but we can detect where sound is coming from and gives us perception about reality. Same thing with our eyes. We have two eyes. We have special algorithms in our brain that lets us detect distances and depth of field. All these things are inputs and outputs that a computer can also utilize for its own purposes. And then, of course, LEDs, because who doesn't like RGB LEDs? And we have motors, a bunch of sensors, all these different tools that we can use to build specific applications. So let's dive a little bit more into the hardware first. So this is a nice little board here, and it's got a really saccharine name, a Raspberry Pi. It's super delicious. This is one of the most popular embedded system platforms out in the world. Not only because it's so user-friendly, but there's a huge community backing it up. There's a ton of tutorials, a ton of people between hobbyists, people that are just learning about computers, and even have experts that are using this as much more advanced configurations for like supercomputers. Crazy, insane stuff. But just as our bodies have different types of hardware that we can use, embedded systems have the same kind of thing. If you want to go on the internet, well, hey, look, you have a Wi-Fi chip that you can utilize. If you want a more stable, fast internet connection, you have an Ethernet that you can just plug into. You have USB ports, which are literally universal serial buses, and we can hook up webcams, maybe a keyboard, maybe a mouse, maybe a flash drive. Maybe we want to build an application that has a webcam and every 10 minutes takes a picture and stores it into a flash drive. We can do that with this kind of board. Other components as well, like audio, HDMI for videos and images so we can display onto stuff. All these things are at the disposal of a programmer. And most of the time with the hardware, there's hundreds upon hundreds of different types of boards, but this is kind of the general idea of what you can select from. And then we move a little bit more to the abstract, which is the software. And I really wish I can condense what software is, but if I could in a single sentence, it would essentially be the soul of the computer, the embedded system. As I mentioned, there's two main parts to software. If you look on the left side, this is kind of like an idea of what the operating system is. If you think of the operating system as a human, think of it as the stuff that we do involuntarily. You know, as your body grows, you don't tell your hair to grow centimeters every day, right? That's just involuntary. This is what your body naturally does. You don't tell your heart to keep pumping blood. You don't tell your brain to formulate a thought and then come out as words. This all comes involuntarily. We have a higher level, an application code, where we can say, oh, I want to do some public speaking. So I know that my brain can handle the low-level murky stuff, and I can just say the words that I want to say. Same kind of concept. The operating system is like the gatekeeper to the hardware. It handles all the low-level stuff that's involuntary, and it gives us the access to use that to program functional things that work. And in this example here, it's just a really quick one. It uses a couple, maybe 15 lines of code. It tells the user to come up with a random number. And every time they enter the number, the computer will tell you if you're too high, too low, or you guessed it. And as you can probably imagine, there's other computer software out there that has millions upon billions of lines of code. Facebook, for example, this is a behemoth of a code base. It has all the mechanisms to keep track of people. When did they log in? What posts do they have? Who do they know? They have algorithms that can detect where you go. They can specify ads, and it just keeps growing and growing and growing. And hopefully you guys can kind of understand those concepts. I know it's a little bit high level, but it's the hardware, the software, and the inputs and outputs. And what I want to do is I found this really cool video of a guy who made an M&M sorting machine. And it's going to be 2 minutes real quick. I want you to just kind of see the project. He's going to discuss the little parts and just kind of pick and point where you can see the hardware and the software that come out. Hopefully that gives you an understanding of how embedded systems not only can be used for practical reasons, but for inventive, creative reasons as well. And with that said, I'm going to move into the question and answer session. So if you guys have any questions, feel free to raise your hand and I'll answer as many as I can. Kevin.
I'm very curious. You said that was an M&M sorter, but those were clearly Skittles. Can you explain that?
I will. I'm glad you actually caught that. So the creator of this M&M sorting machine actually made it both sort M&Ms and Skittles, and he has control buttons to select which one to sort. Because M&Ms and Skittles have two different color codes, so when you have a color sensor, you got to know which one you're sorting. Great question. Any other questions? Can you build a Can you build a Raspberry Pi at home? Actually, there are people who build their own custom boards, and they use the Raspberry Pi schematics and files, and they want to make it smaller. Maybe they want to add more peripherals for more internet or Bluetooth. So yeah, they actually are able to build those. I haven't actually built my own, but I have been able to use other smaller boards and build those as well. Question?
What are some of the embedded systems that you designed? What are their preferences?
All right, so one of the very first embedded systems that I designed was back in college. It was for a micro mouse competition. So this is a competition that's held in San Diego State University. And the whole purpose is to build a little autonomous micro mouse. It's a little tiny robot that goes into a maze with all these little small, about 5-inch high walls. And what you do is you set it in there, and it's supposed to drive itself and figure out the maze in the course. And you have about 30 minutes to figure this out. And the other part of the competition is not only for it to be able to detect the walls, drive the motors, get to the end goal, but see if it's smart enough to detect the fastest path. So when you do the second run, you compete against other people. Whoever has the fastest competition speed wins. So that's probably one of my first and favorite embedded system designs. Any other questions? Bobby?
I don't know how to ask, but I got this back cleaner on my phone. Underneath it, it's got 1, 2, 3, 4, 5, 6 other components added to it. Now, the back cleaner used to be one of those things you talked about on the right stuff up there.
On the left?
I don't know, just keep it as a back piece.
Oh, you're talking about my presentation, right?
Yeah, I understand all these systems work, but every time I hit one button for the cleaner, it gives me something else to clean or do something to fix it. I say, what the heck's all this one stuff for? I don't understand it. Now, this back cleaner, would that be like a hardware part of it? Software, all these other little things to go with it?
Usually,
To activate each and every one of them, you just get this one thing and activate it.
usually depends. Whoever designs it, depending on the experience level of most engineers, they might over-engineer it, they might under-engineer it. So there's really no design pattern based on what they want to make. Something as simple as like a fitness watch. We've seen knockoffs that you can buy on eBay for like $10. But the reason that people are able to do that is because they cheap out on components, or maybe there's not enough functionality, or maybe they have weaker batteries. So it's really hard to say exactly why in your situation you have to do all this finagling with the hardware. It might be that it's just maybe a subpar cleaner, or there should be documentation though online to help you find out how to reset it or how to use it. I can help you out after the meeting though, if you want. Question?
My friend would say you work in the casino industry, so what do you do for them in the casino industry?
Okay. So good question. One of the in the casino industry, you have, specifically for me, right now, I work with table games. So imagine blackjack, poker, 21. And we want to add electronics to this table so we can acquire player wager information. So if you've walked around a casino floor, you might see that they have these little sensors next to the wagers that you can bet on. And if you put a chip on top of it, the LED might start glowing. And then the dealer might have a button where they can lock it in. And then that wager will show up on a display next to the table. And maybe that same exact wager will go to a back-end computer, which gets processed. And then it starts incrementing a progressive value. And then that can be sent out and audited and logged. So that's kind of essentially where the embedded system part that I do on a day-to-day basis for the casino industry comes into play. Questions? Yes?
Are they tracking the play, or are they tracking the money from the table? Are they trying to bust somebody flipping them off, or are they just tracking your play?
Are they trying to? They're usually tracking play so you can do progressives. So the whole point of our system, it does do auditing. Just because we need auditing, we have to know that, oh, you say that $1,000 were played on this table. How can you back that up in case data gets corrupted? But the main point is to detect the wager, to increment a value. So when somebody keeps playing this table here and this table over there, they have the same exact value. And if somebody wins, they get the right amount. So it's not more about the tracking. It's more about using that information to create a product that can make a more global game, if that makes sense.
Speaking of global, is Skynet on its way? Is that what you're saying?
So the question is Skynet on the way? Probably, yeah. I got time for one more question.
So now it tracks the game, so all the bets and the table wins are linked to a progressive, right?
Mm-hmm.
So these games can be all over the state of Nevada, all over the country, right? They're all linked, right?
Yeah, so there's definitely jurisdictional rules with that as well, though. Some of the big things in casinos is Wi-Fi is a big no-no. They want to have tethered lines, which is another benefit of using Ethernet, for example. It's a hard wire, so you can't just have somebody walk up into a casino floor and start sniffing information wirelessly. With a hard cable, you need to literally be able to access that cable to get the data. I mean, in terms of that, there is workarounds. You can use virtual private networks. So even if somebody does access the Wi-Fi for some reason, all the data is encrypted and it'll just look like a bunch of garbage to them.
So it's all hard cabling, right? The information travels through hard wires.
It depends on the casino. Sometimes they might have a table which has a router, which then connects to their network, and then there it goes to a hard wire to another casino so they can get linked. But it's all IT at that point. Thank you. And with that, that's my presentation. And thank you. I'll return back to my Toastmaster.